students, we were talking about how to represent irrational numbers on a number line, right? Till now we have talked about how to represent numbers of this form, that is root 2, root 3 or root 5, that is square root of integers on a number line. Now we will be talking about how to represent a number having decimal form and its under root on a number line, right? Let us say for the first case 4.5 or square root of 4.5. So what I am going to do is I am going to consider 4.5 as x, right? So root over 4.5 will be equal to root of x, right? So the first step says draw a line segment, let's say AO, which is equal to x, right? The first step says draw a line segment AO which is equal to x. So what I am going to do is I am going to draw, let's say this is AO which is equal to 4.5. This is equal to 4.5, right, or x, right? Now the next step is we need to extend this line AO to a point B such that we are adding 1 unit to this line segment, right? Extend AO to B such that S/T, it stands for such that OB is equal to 1 unit, right? So what I need to do next is I need to extend this point O till B, right? So that this length OB, this is equal to 1 unit, right? So in the first step I draw the length, that is 4.5 or x. Then in the next step I added 1 unit line segment to it and extended it to point B, right? Now in the third step what I need to do is I need to draw a semicircle considering AB as the diameter. Draw semicircle with diameter AB, right? Draw a semicircle with diameter AB. So let us say that this is a semicircle. Let me make a better semicircle. Right? This is a semicircle which we have made by making AB as a diameter, right? The semicircle, it intersects point A and point B, right? So AB is a diameter of the semicircle, and let's say the center of the circle is a point C. The center of the circle is a point C. Now what you need to do next is you need to make a line segment from point O such that it lies on the semicircle as well, right? So extend O to meet semicircle at, let's say, point D, right? So what I have done is I have drawn a line segment, right? Now you need to remember that this line segment should be perpendicular. So I need to say extend O to meet semicircle at D such that OD is perpendicular to CO, right? OD is perpendicular to CO. So this is perpendicular, right? When we have done all this construction, then I can say that OD is equal to root x, right? Or this was the required construction. OD, the length of OD is nothing but root over x. This length is root over x, right? We'll be learning the proof of this construction or this method later. First, what we need to know is that if the length OD is equal to root x, then what we need to do? We'll be drawing a number line, right, with its axis coinciding with AB, right? And what we'll be doing is we'll be transferring this root x on the number line. Let us see how. What I'm going to do is I'm going to rub the rest part, right? Let's say without rubbing, if I want to draw a number line, I'm drawing a number line which coincides with the, this is a number line which coincides with AB, right? And this point, which is very important, the point O is nothing but the origin. The point O is our origin or the center point, right? So our positive numbers, they will lie on this side, our negative numbers, they will lie on the left hand side. So this number, because this is 1 unit, so B will be equal to 1. Similarly, we will have 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side, and minus 1, minus 2, minus 1, minus 2, minus 3 on the left hand side, right? So what we need to do is we need to transfer this length OD on the horizontal axis. So what we are going to do is we are going to pivot a compass on the point O, and with radius OD we are going to make an arc to intersect this number line, right? So pivoting our compass at point O, we made an arc, right? This is an arc, right? As we can see that this intersects the number line, let's say at point E, right? I can clearly say that OD is equal to OE, which is equal to root over x or root over 4.5. Why? Because OD and OE, they are radius of the same arc, right? They are radii of the same arc. You will be learning more about this in lines and angle. When we use a compass to make two arcs of same radii, then both the arcs are equal to each other, right? Or both the radii, they are equal to each other. OD and OE, they are equal to each other, right? Because we have drawn a common arc. Now let us look at the proof why the line segment OD, it gives us root x or root 4.5, right? So I can say that because COD, this angle is equal to 90 degree, what I am going to do is I am going to join C and D. This is our construction. We are going to join C and D. Let us see the proof of what we have done till now, right? So first of all, what we have is we have right angle triangle COD, right? Now by Pythagoras theorem, right, the prerequisite for this method is Pythagoras theorem. Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other side, right? So this is CD square, which is the hypotenuse square, is equal to CO square plus OD square, right? These two are the other sides. So square of the hypotenuse is equal to the sum of the squares of the other two sides. This is nothing but Pythagoras theorem. Pythagoras theorem, right? We'll be using this theorem to find out the length of the line segment DO, right? This DO or OD we need to find. This is a target. So I can say that AO is equal to x, right? And OB is equal to 1 unit. And we have drawn a semicircle considering AB as the diameter, whose center point is C. So I can say that the radius AC or CB, AC or CB, which are nothing but the radius of the semicircle, they will be equal to x plus 1, which is the diameter. So half of the diameter, half into dia, right? Radius is always equal to half the length of diameter, that is x plus 1 by 2. So I can say AC and CB, they are equal to x plus 1 by 2. Similarly, I can say that CO, the length CO, it is equal to AO minus AC, right? AO minus AC. AO minus AC will always give CO, right? We know what is AO. AO is nothing but equal to x, and what is AC? AC is nothing but equal to x plus 1 by 2. So x minus x plus 1 by 2 will yield x minus 1 by 2, right? So we have CO as x minus 1 by 2, right? Similarly, we have AC as x plus 1 by 2. We know that CD, this length CD, it is nothing but the radius of the same semicircle. So I can clearly say that CD will also be equal to x plus 1 by 2 because they all are radius, AC, CB and CD. So substituting the value of, this is important because this is the value of CD which we are going to put here, and this is the value of CO which we are going to put here. So substituting these values here, what I am going to get is, let's say OD square, right? We'll take CO on that side. So OD square will be equal to CD square minus CO square. Substituting the values, x plus 1 by 2 square minus x minus 1 by 2 whole square, right? Now we'll be using one identity which is a plus b whole square. Now what is a plus b whole square? Let me write it here, right? A plus b whole square, it is a square plus 2ab plus b square, right? These all are identities. Identity means that if we put any value of a and b, this equation will always be satisfied. That is called an identity, right? Similarly, we have a minus b whole square is equal to a square minus 2ab plus b square, right? We have already done these identities in previous classes. So using these identities, we can solve this equation. X plus 1 by 2 square will be taking 1 by 4 common, because 2 square will become 4. Here also 2 square will become 4. So 1 by 4 common. We will have x square plus 2x plus 1 minus of, right, x square minus 2x plus 1, right? This is the equation that we have got, squaring of both x plus 1 and x minus 1, right? When you open the bracket, I can see that x square and x square, they will cancel out, x square they cancel out, 1 and 1 they cancel out because minus of 1, right? And what we are left with is nothing but 2x minus and minus of 2x, which will become 4x. So 4x by 4, which is nothing but x, right? So we have OD square equal to x. So we can clearly say that OD will be root of x. We have taken root on both the sides, so OD will be root of x. So that is what we needed to find out, right? We have proved that OD, the length of OD is nothing but equal to root x, and root x is the length that we need to plot on the number line. So this was the proof, and we have plotted 4.5 on the number line.